Good morning, everyone. My name is Nidhi. I'm going to walk through a small foreground project I built that is a real-time red light violation detection system. It is a proof of concept that simulates an IoT camera at the edge, filters events at the fog layer, and streams only violations to the cloud where they are stored in DynamoDB. This work is based on an existing IEEE paper that proposes a three-layer approach for traffic pedestrian violation monitoring, sensors at the edge, fog nodes for local filtering, and a cloud layer for large-scale processing that uses Kafka and Spark. I implemented the same architecture idea but with AWS, a Python 8 simulator, a Flash fog server, AWS Kinesis at the stream, and DynamoDB as storage. My scope is a single module, red light violation detections, which is enough to demonstrate for edge generation, fog filtering, and cloud ingestion. This is my architecture diagram. All the Python scripts are executed in Amazon EC2. So there are like three layers: edge layer, fog layer, and the cloud layer. So the edge layer will simulate the traffic events. So like it'll just keep generating the number of traffic events, and this edge layer will push the data to the using HTTP post to a Flask server in the URL, that is slash ingest URL, where the Flask server will be listening. And fog layer will capture all the traffic events from the slash ingest URL and process and selects only the valid traffic events, that is selection of the traffic violations based on the Boolean flag. And this layer will just push the valid traffic violations to Kinesis, where it will be stored for temporary storage and for further processing. And the cloud layer is another Python script that will consume to this stream and process the data and stores the data to DynamoDB. Now I'll just walk you through the code of this thing. So I'll just click on. So in this, so this is the fog server file. So here we just set up the path and the Kinesis name and the stream name. So here we just consume the Kinesis part, and we just process the valid traffic violation. So I'll just stop this. So I'll just run this fog server so that the fog server can listen to the its files. As you can see, the fog service is running on this URL. So now I'll just go to the second terminal. So I'll just click on nano, hit some verify. The corresponding fog URL where the data will be sent. And here we simulate the this thing, the data, that is we can see like car cross and red light as a Boolean choice. And we just HTTP post to the corresponding fog URL for the fog processing. So I'll just so we can just keep this as it is for now. So I'll just go to the I'll just show the code for the cloud processing. So here we can see we just connect to the in this part we just consume whatever the fog server is sending data to the Kinesis. We are just trying to consume to the corresponding stream name, and we just try to insert the data to the corresponding. As long as we get the data from the Kinesis, we just trying to insert data into the corresponding DynamoDB. So I'll just go and simulate the. So first of all, I'll just run this cloud processing code so that we can connect to the corresponding stream. As we can see, it is even the cloud process starting, and even the fog server is running. So even the fog is running in this address. So I just now start the which it's the thing. As I can see, like the Python Edge simulator will just try to simulate the traffic events. So we can see the frame number and has been streamed. So we can just go to the here. We can see we got the 201 address for first violation. And yeah, as we can see, the cloud processing is picking up the data from the streaming process, and it's inserting the corresponding data into the DynamoDB. So I can just show the output to you to the DynamoDB. So as we can see, the number of items has been increased to 20 for now. So we can just check for one of the data. So we can just pick for 18. So as we can see, what are the data the code has been sent? It is be able to see in the DynamoDB. This is the project that we built to demonstrate the fog edge computing in the processing of data in the cloud. Thank you.